Complete step-by-step walkthrough of the November 2018 Edexcel Higher GCSE Maths Paper 1. Let's do this. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Just quickly before we get going, the paper itself is available down below in the description. My playlist with every Edexcel higher paper is also down there. My brand new formula booklet video is down there, as well as useful links and playlists to help with topics on this paper. I'll keep you posted on those as we go. Okay, let's do this. Okay then, question number 1. So straight away, indices. I've got a brand new playlist on these, it's down below. So we want to work out the value of 3 to the 7 times 3 to the minus 2 all over 3 to the 3. Okay, so by the rules of indices, up on top, when we're multiplying, we add the indices. So that's going to give us 3 to the power 5 on top. And on the bottom, we have 3 to the power 3. Now that means 3 to the 5 divided by 3 to the 3. So by the division rule, we subtract the bottom power from the top. So we are going to get 3 to the power of 2. Which, of course, is 9. Okay then, for number 2, v squared equals u squared add 2as. U is 12, a is minus 3, s is 18. We want to work out the value of v. Okay, so we want to substitute these values into u squared add 2as. So we're going to get v squared is equal to, so 12 squared add 2 times minus 3 times 18. So that's going to be minus 6 times 18. Okay, now then, 12 squared is 144. Now 6 times 18, well 6 times 10 is 60, 6 times 8 is 48, so that's going to be minus 108. So that is going to give us that v squared is equal to 36. Therefore, v can be positive or negative 6. Okay, then part B answers to make s the subject of the formula v squared equals u squared add 2as. So that means to get s on its own, everything else on the other side. So, first of all, I'm going to subtract u squared. So we're going to get v squared minus u squared is equal to 2as. Now the 2a is multiplying the s, so we can think of 2a as being one whole thing. To cancel out a multiplication, we divide, so we get v squared minus u squared all over 2a is equal to s. Okay, number 3. So it's a 5 marker already, no messing around. So a bonus of £2,100 is shared by 10 people who work for a company. 40% of the bonus is shared equally between 3 managers. The rest of the bonus is shared equally between 7 salesmen. One of the salesmen says, if the bonus is shared equally between all 10 people, I will get 25% more money. Is the salesman correct? You must show how you get your answer, of course. Okay, so let's go through it in the order it's in. So let's first of all find out 40% of 2,100. So 10%. In fact, we don't even need to do that. Let's find 10%. So 10% of 2,100 is £210. Now, if the money was shared equally between all 10 people, they would each get £210. So that is the amount if equally shared. Between all 10. Now, as it goes, the salesman altogether only get 60%. So, 60% of 2,100 well, that's going to be 6 times 210. So 6 times 200 is 1200, 6 times 10 is 60. So that's going to be 1260. Now, to work out how much one salesman gets, we now need to divide that by 7. So, each salesman gets 1,260 divided by 7. So, if we use the bus stop, then we need to do 1260 divided by 7. So 7 into 1 not happening. Carry the 1. 7s into 12 go once. With 5 remainder. 7s into 56 go 8 times. and then 7 into 0 goes 0. So each salesman gets £180. Now, what this salesman up here is saying is that if they shared the money equally between all 10 of them, he would get 25% more money. So, to test his claim, we now need to find 25% of 180 and add it on and see if we get £210. So, 25% of 180 well, half is 90, half of 90 is 45. Now, 180 add £45 is £225, which is not £210. So the answer is no. He is not correct. Okay, number 4 we have proportion, so I do have a playlist down below. So it would take 120 minutes to fill a swimming pool using water from 5 taps. Per day, how many minutes would it take to fill the pool if only 3 of the taps are used? Okay, so this is inverse proportion. We need to assume, although I see this is full party, to be able to do this so we need to assume water flows out of each tap at the same rate. So if we first of all find out how long it would take one tap, so if we divide the number of taps by 5, the time it's going to take multiplies by 5. So one tap would take 5 times 120 minutes, so that's 600 minutes. Now, we want 3 taps, so if we're now multiplying the number of taps by 3, we divide the time by 3, so that's gonna have to be 200 minutes. And then for part B, we've already answered that. State one assumption you made in working out your answer, part A. So our assumption is that each tap has water flowing out at the same rate. Okay, number 5. A plane travels at a speed of 213 miles per hour per day and has to work out an estimate for the number of seconds the plane takes to travel 1 mile. Good times. Okay, so given that this is a non-calculator paper, we're going to need to use approximation. So I'm going to round 213 down to 200. So to show that, we can use a squiggly grey word equals sign like that. So that means 213 is approximately 200. Now, we're also going to need to turn 1 hour into seconds. So, 1 hour is 60 minutes, and each minute is 60 seconds. So it's 60 times 60. Now, 10 times 60 is 600, 6 times that is 3,600. Okay, so we now know then that we go approximately 200 miles in 3,600 seconds. We want the time to go 1 mile, so we divide by 200. So we get 1 mile is 3,600 divided by 200 seconds. So, both numbers there end with 2 zeros, so they have a common factor of 100. So this is the same as 36 over 2, or 18 seconds. Okay, so depending on your rounding, you might get a slightly different answer. A mark scheme wants between 16 and 20. Okay, then part B wants to know whether our answer is an underestimate or an overestimate, giving a reason for our answer. So, we need to think about what we've done. We rounded 213 down. Now that was the distance that the plane travels in 1 hour. So we rounded down from 213 to 200. So our plane has a slower speed than the actual plane. So our plane is going to take longer to go 1 mile than the real plane, because the real plane is going faster. So our answer is an overestimate, and the reason being our plane is going slower than the plane going at 213 miles per hour. Okay, for number 6, we have simultaneous equations. I have a whole playlist on these down below. So we want to solve 5x and y equals 21 and x minus 3y is equal to 9. Okay, so the trick of these is to, first of all, call them 1 and 2. Okay, now we need 2 equations with the same amount of the same letter. So, with these, we only need to change 1 equation. So, I'm going to make the y's the same. So, to do that, I need to turn 1y into 3y. Doesn't matter that 1 is positive and 1 negative, we can deal with that. So, I'm going to multiply equation 1 by 3. Now, that is going to give me 15x, add 3y is equal to 63. Now we're going to call that equation 3. So, now 2 and 3 both have 3y in them. Now because one is negative and one positive, we have to add the equations together. So we're now going to do equation 2 add equation 3. So we're going to get 16x. The 3y and minus 3y cancel each other out. And on the right, 9 add 63 is 72. Okay, so now we have an equation just in terms of x. We can find out what x is. So, probably doesn't look very nice. We could first of all divide both sides by 2 to make it a little bit less scary. So if we do that, we will get 8x is equal to 36. You can even do that again if you like. 4x is 18. 2x is 9. So x is 4.5. Now that we know what x is, we need to find y. So we substitute x back into one of these equations. So I'm going to use equation 2. So x minus 3y is equal to 9. So that means 4.5 minus 3y is equal to 9. Now if we add the minus 3y, we get 4.5 is equal to 3y add 9. Take away the 9. 4.5 minus 9 is minus 4.5. So minus 4.5 is equal to 3y. Divide by 3. We get y is minus 1.5. So there are the solutions. X is 4.5, y is minus 1.5. Okay, number 7, this one looks fun. So, the diagram shows a square, ABCD, with sides of length 20 centimeters. It also shows a semicircle and an arc of a circle. So the semicircle is the white down the bottom, and the arc is the top of the shaded bit going from A to C. Now we're told AB is the diameter of the semicircle, AC is an arc, is an arc of a circle with centre at B. So that means if that semicircle wasn't there at the bottom and it was all shaded, then that would be a quarter of a circle. We want to show that the area of the shaded region over the area of the square is pi over 8. Okay, so we're going to need to work out 3 areas. The area of the square, area of the semicircle, and the area of the quarter circle. So, the area of the square is 20 times 20. So 20 centimeters times 20 centimeters is 400 centimeters squared. Let's now do the semicircle. So this guy is going to have a radius of 10 centimeters. So area of a circle is pi r squared. So the semicircle is going to be pi times 10 squared over 2. So that's 100 pi over 2, so that's 50 pi centimeters squared. Now to work out the quarter circle, now this guy has a radius of 20. So, again, area of a circle is pi r squared. So we're going to do pi times 20 squared divided by 4. So, we're going to get pi times 400 all over 4, which is 100 pi centimeters squared. Okay, so now that we know the area of the quarter circle and semicircle, we can work out the area of the shaded region. So, the shaded region is the whole quarter circle minus the semicircle. So that's 100 pi minus 50 pi, which is 50 pi centimeters squared. So then, the shaded area over the square, so shaded area over the square is 50 pi centimeters squared over the area of the square, which is also centimeters squared, so the centimeters squared cancel out. So the area of the square was 400 centimeters squared. So we have 50 pi over 400. Now there's a common factor there of 50, so we do get pi over 8. Okay, number 8, we have exact trig values, which I have a brand new playlist on, and socket tower, which I also have a playlist on. Both are down below. Part A wants us to write down the exact value of tan 45. So, tan 45 is 1. If you don't know how to calculate exact trig values, check out the playlist down below. Then for part B, we have a right angle triangle, where we know one angle is 60, the adjacent to that is 4, and the hypotenuse is x. Our job, or we're told, cos of 60 is 0.5, and our job is to work out the value of x. Okay, so this side is the adjacent, x is the hypotenuse. So, are we using so, no, ca, yes. So, ca tells us cos of 60 is equal to the adjacent 4 over the hypotenuse x. Now, we need to get x up from the bottom, so we multiply through by it. Now we also know cos 60 is 0.5, so we can say that 0.5x is equal to 4. Now we could divide both sides through by 0.5, or just multiply both sides by 2. So x is 8. Okay, number 9 are the times that 48 trains left the station on Monday were recorded. The cumulative frequency graph gives information about the numbers of minutes the trains were delayed, correct to the nearest minute. Okay, our first job is to draw a box plot. So we are told the shortest delay was 0 minutes, the longest delay was 42 minutes. So part A, on the grid below, draw a box plot for the information about the delays on Monday. Okay, so we have our two whiskers. So they are going to be at 0 and 42 minutes. So it doesn't matter how tall the box is. So I'm just going to use the bottom half. So our left whisker is at 0. And our right whisker is at 42. So each little square is worth 1. So there are the whiskers. Now we just need the median and the quartiles. So the median is the middle value. Now remember there are 48 trains, not 50. So half of 48 is 24. So we find 24 over here, which is there. Go across until we hit the graph there, and then go down to the x-axis. So the median is 10. So that's the line that's going to be in the middle of the box. Well, not in the middle, but inside the box. And then for the quartiles, we need to find a quarter of 48 and 3/4 of 48. So a quarter is 12. So that's there. Go across to the graph and we get 4. So the left of the box is a 4. And then for the upper quartile, we go across from 36, which is there. Takes us here, which is 20. So then, we just need to draw the box. So obviously you don't need to use different colours. I'll just use them to show different parts. And in the real thing, make sure you use a ruler. So that is our box plot. Okay, next up, 48 trains left the station on Tuesday. The box plot below gives information about the delays on Tuesday. So part B wants us to compare the distributions of the delays on Monday with the distribution of delays on Tuesday. So that's 2 marks. We need to make 2 comparisons. Okay, so first of all, the first thing that hits me is the range of delay times on Monday was greater. So that means the range of times the delays could have been are more spread out, more varied. And then the second thing, if we compare the medians, we can see on Monday it was 10. On Tuesday it was 9. So for that one we can say the median delay time on Monday was greater than the median delay time on Tuesday. Okay, and for part C, Mary says the longest delay on Tuesday was 33 minutes. This means that there must be some delays of between 25 minutes and 30 minutes. Is Mary right? You must give a reason for your answer. Okay, let's check that the 33 is right. Okay, so that's right. Now then, is she right now in what she is saying? The answer is no. So the 33 being the greatest delay time acts as the right whisker. So it might be that 33 is an outlier. So that might mean under 33, the next delay time might be 20 minutes, or 19 minutes, or 18 minutes, for example. So there doesn't have to be any delays on the line connecting the box with the whisker. So she's wrong. Okay, number 10A, one says to simplify x minus 1 over 5 times x minus 1 squared. So, between the top and the bottom here, there is a common factor of x minus 1. So it might help to put the top in brackets. Maybe you don't have to. So what we can do here is divide top and bottom by x minus 1. So on top we get 1. And on the bottom we get 5 times x minus 1. Now it says simplify, so we should expand the brackets too. So this is 1 over 5x minus 5. Okay, then part B says factorise fully 50 minus 2y squared. So this is almost a difference of two squares. If you don't know what they are, check out my quadratic playlist down below. Now there is a factor of 2, so let's take that out. So we're going to get 2 lots of 25 minus y squared. Now 25 minus y squared is a difference of 2 squares. So we can now say this is 2 times 5 plus y times 5 minus y. Okay, number 11. This is going to be a really weird one to explain, but I'll do my best. So, Jack and Sadia, maybe, work for a company that sells boxes of breakfast cereal. The company wants to have a special offer. Here is Jack's idea for the offer. So, put 25% more cereal into each box and do not change the price. Sadia's idea is to reduce the price and do not change the amount of cereal in each box. Sadia wants her idea to give the same value for money as Jack's idea. So that means the same amount of cereal needs to cost the same amount of money. By what percentage does she need to reduce the price? Okay, so this is a question where we need to be clever about the numbers that we choose. So I'm going to, for the sake of ease, say that a normal box has 100 grams and costs £1. Okay, now then, by Jack's offer, so Jack wants to increase the amount of cereal by 25%, but not change the price. So with Jack, we are going to get 125 grams for £1. Now, Sadia is not going to change the amount of cereal, she is going to change the price. Now, what we need to think then is, can we think of an amount of cereal that goes into 125 grams that also goes into 100 grams? So, the one that strikes me is 25 grams. So, from Jack, if we divide by 5, 25 grams costs 20p. So, for Sadia, we need that same value. So, we need it to be 25 grams costing 20p. Now she's going to have 100 grams in her box, so if we multiply that by 4, 100 grams has to cost 80p. Now that then is a 20p reduction, which then has been a reduction of 20%. In number 12, circle theorems playlist down below. So A, B and C are points on the circumference of a circle, centre O. D, A, E is the tangent to the circle at A. Angle BAE is 56 degrees. Angle CBO is 35 degrees. Work out the size of angle CAO. You must show all of your working. So let's find CAO. So that then is going to be this guy here. Okay, so how are we going to do that? Well, a radius and a tangent meet at 90 degrees. So we know this whole angle here is 90 degrees. Now that allows us to work out this angle. So 90 minus 56 is 34 degrees. So this angle here is 34 degrees. Now this triangle here in the middle, BOA, is isosceles because both of these lines are a radius of the circle. So this angle up here is also 34 degrees. From that, we can work out the angle at O. So 34 and 34 is 68. 180 minus 68 is 112. So this angle here is 112. Okay, now then, from that we can get the angle over here on the tip of the arrow. That angle is half the angle at the centre. So half of 112 is 56. So this guy is 56 degrees. Now then, the angle that we want, this guy, is inside of this arrowhead, which is a quadrilateral. So if we know the three other angles, we can work out this fourth one. Now the other one that we can work out is this guy. So that guy is 360 minus 112. So that is going to be 248. So, if we now add 248, 35 and 56, that's going to give us 8 and 5 and 6 is 19. 1, 4, 3 and 5 is 13. 1 and 2 is 3. So at the moment all the angles inside the arrowhead add to 339. So our guy is then 360 minus 339, which is 21 degrees. Okay, number 13, we want to describe fully the single transformation which maps triangle A onto triangle B. Okay, so we can see triangle A has got smaller and turned around. So it's going to be some sort of enlargement. Now, what's the scale factor? Now, because the triangle has flipped over, it's going to be a negative scale factor. Now we can see that the height of the triangle was 3, it's now 1, so the scale factor is minus a third. Then we need to find the centre. So the point at which it's been enlarged with reference to. So to do that, we need to join up two pairs of corresponding points on these triangles. So for example, the corners like that would be one pair, and then we go with that guy corresponds to that guy. Okay, so I've just sharpened that up. You do need the lines to be exactly on the points. Now the point where these two lines meet. So here is the centre of enlargement. So it's the centre of 2, 2. Cool. Number 14, more fun with indices. So first up, we want to work out the value of 1681 to the power 3/4. Lovely. So, with fractional powers, and remember my playlist on indices is down below. With fractional indices, we split the power. So we're going to have 1681 to the 1/4 all cubed. Now setting something to a power of a quarter wants the fourth root. So 2 times 2 times 2 times 2 is 16. So 16 to the quarter is 2. 3 times 3 is 9, times 3 is 27, times 3 is 81, so 81 to the quarter is 3. So we now have 2/3 cubed, so cube the top, cube the bottom, we've got 8 27ths. Okay then, part B. I bet everybody I loved this question. So, 3 to the power A is 1/9, 3 to the power B is 9 root 3, 3 to the C is 1 over root 3. We want to work out the value of A plus B plus C. So, working through each one separately, then we need to turn the thing on the right into a power of 3. So, 3 to the power A is 1/9. So 9 is 3 squared. 1 over 3 squared is 3 to the minus 2. So A is minus 2. 3 to the power B is 9 root 3. So 9 is 3 squared. Root 3 is 3 to the half. By the rules of indices, we add the powers because we're multiplying. So 2 and a half is 5 halves. So B is 5 halves. And then 3 to the C is 1 over root 3. Root 3 is 3 to the half. 1 over it is 3 to the minus half. So C is minus 1/2. So A plus B plus C then is minus 2, add 5 halves, minus 1/2. Now minus 2 minus a half is minus 5 halves. So this is actually just 0. So only 2 marks for that is crazy silly. Okay, number 15, we have solid shapes and combining ratios. Good times. So, 3 solid shapes, A, B and C, are similar. The surface area of shape A is 4 centimeters squared. Surface area of shape B is 25 centimeters squared. We are told the ratio of the volume of shape B to the volume of shape C is 27 to 64. We want to work out the ratio of the height of shape A to the height of shape C, giving our answer in its simplest form. Okay, so we can first of all write down a ratio for the surface area of A to B. So, surface area then of A to B is 4 to 25. Now, from surface area ratio, you can get the length ratio by square rooting. So the lengths of A and B are in the ratio 2 to 5. Okay, and then we're told the ratio of the volume of B to the volume of C is 27 to 64. So, for B to C. The volumes are in the ratio 27 to 64. Now, to get from volume ratio to length ratio, we cube root. So the length ratio of B to C is going to be 3 to 4. So what we need to do is combine the two length ratios because we want the ratio of A to C. It doesn't matter that it specifically said height because all the lengths are going to be in the ratio that we find. So what we need to do then is make it so that the part in both ratios is the same number. So the bit that turns up in both length ratios is B. So, in the left-hand ratio, B has a value of 5. In the right-hand ratio, B has a value of 3. So the first number 3 and 5 both given to is 15. So we're going to change both ratios so that the B part is 15. So on the left, we are going to get 6 to 15. On the right, we are going to get 15 to 20 because we're multiplying by 5. So we can actually write this now as a single ratio, A to B to C. Is 6 to 15 to 20. Now we want A to C, so we just cut out the middleman, cut out B. So A to C is 6 to 20, which simplifies to 3 to 10. Number 16 wants us to prove algebraically that 0.256 recurring can be written as 127 over 495 times. So I do have videos on recurring decimals to fractions down below. Okay, so we start off by setting a letter. So I'm going to use x final equal to the decimal, so 0.256 recurring. Now the first thing that we need is a number with a purely recurring decimal. So at the moment this isn't purely recurring because the 2 is not in the pattern. This means 0.2565656 forever. So the first thing we're going to do is multiply through by 10. So we're going to get 10x is 2.56 recurring. Now we need another number with that exact same recurring decimal. So we need to move the decimal to the right 2 places. So we now multiply through by 100. So we're going to get 1000x is equal to 256.56 recurring. Now we can lop off the recurring part using subtraction. So we now do 1000x take 10x, which is 990. So 990x is equal to 256.56 recurring minus 2.56 recurring, so that's just 254. Now we want to get x on its own, so we now divide through by 990 and we get x is equal to 254 over 990, which happily does have a common factor of 2 and is 127 over 495. Okay, number 17, so we have a sketch of a curve. The equation of the curve is y equals x squared add ax add b, where a and b are integers. So it's worth pointing out here, with a quadratic, the number without an x is the y-intercept. We're told the points 0, -5 and 5, 0 lie on the curve. So 0 minus 5 happens when x is 0. So that is this point here. Now that actually tells us b is -5. And then the other point, 5, 0, it's going to be this guy over here. Now, our actual job is to find the coordinates of the turning point of the curve. Okay, so what we want are the coordinates of this point down here. Together, we are going to need to know the other x-intercept. So, how are we going to do that? Well, we now know that b is -5, so we now know y is equal to x squared add ax -5. Now, because we know 5, 0 lies on the curve, we can find the value of a. So we know when x is 0, when x is 5, y is 0. So that tells us then 0 is equal to 5 squared, so 25. Add a times 5, so add 5a. Minus 5. So that tells us then 5a add 20 is equal to 0. Take away the 20. 5a is -20. So A is minus 4. So then, we now know then y is x squared minus 4x minus 5. Now I did say to find the turning point coordinates we would need the other x-intercept. We could do it that way because the x-coordinate is exactly halfway between. Because it's good practice, I'm going to use completing the square. So, if we write this in completed square form, we're going to get y is equal to x minus 2 all squared. Then we have the minus 5. And we also have to subtract 2 squared on the outside, so that's going to give us minus 4. So, in completed square form, y is x minus 2 squared minus 9. So the turning point coordinates are positive 2 minus 9. If you don't like completing the square, to do it we could also have factorized y equals minus 4x minus 5, find the other x-intercept, find the midpoint between the two x-intercepts, that will give us the x-coordinate of the turning point, and then to find the y-coordinate, substitute that x value into the equation. Okay, number 18. The graph of y equals f of x is shown on the grid below. Part A, on the grid above, sketch the graph of y equals f of x minus 2. So, that is a translation to places to the right. So, every point just moves 2 places to the right. So, we are going to have an x-intercept at 4, an x-intercept at 2, so then the bottom of the graph is going to be at 3, and then the top point on the right is going to be 2 to the right, so that, and then top left of the graph, it's going to be that. So, that is the sketch of our translated graph. Okay, then for part B, graph A has been reflected to give graph B. The equation of graph A is y equals g of x. Write down the equation of graph B. So, we can see these two graphs are symmetrical through the y-axis. So graph A has been reflected through the y-axis. Now the transformation that does that is that the x becomes minus x. So graph B is y is equal to g of minus x. Number 19, we have functions in all their glory, so I do have a playlist on all of this stuff down below. So for all values of x, f of x is x add 1 squared, and g of x is 2 lots x minus 1. I'll tell you once to show that g f of x is equal to 2x times x add 2. So g f of x means we are putting the f function into the g function. First of all, I'm going to expand the g function. So g of x is 2x minus 2. Now then, g f of x so all this means is any x in g of x becomes the f function. So x add 1 squared. So g f of x is 2 lots of x add 1 squared minus 2. Okay, so we're obviously going to need to simplify that. So x add 1 squared, remember, means x add 1 times x add 1. So we have 2 lots of x squared add 2x add 1 minus 2. Now if we expand, we have 2x squared add 4x add 2 minus 2. So the add 2 minus 2 cancel out, so let's get rid of those. Now then, this has a common factor of 2x. So if we factor that up, we have 2x. Now 2x squared divided by 2x is just x. And 4x divided by 2x is just 2. So that is what we wanted to show. So, jobs are good. Okay, then part B wants us to find g minus 1 of 7. So, g minus 1 means the inverse g function. So g minus 1 of 7 means the value of inverse g when x is 7. So we need to find the inverse g function first of all. So the way to do this is, so to cut down the notation, I'm going to write g of x just as g. So we know g is 2x minus 2. Now to find the inverse, we first of all want to now make x the subject. So add 2. So g add 2 is 2x. And then divide through by 2. So g add 2 over 2 is equal to x. Now what happens is the x and g swap places, and g is now the inverse g function. So we get x add 2 all over 2 is equal to inverse g. Therefore, inverse g of 7 is 7 add 2 over 2, so 9 over 2, which would be fine. You could of course write that as 4.5. Number 20, nice big side question, so playlist and all side things down below. We want to show that root 18 add root 2 all squared over root 8 minus 2 can be written in the form a times b add root 2, where a and b are integers. Alrighty, so let's just deal with the top and bottom separately. So we can certainly simplify root 18 add root 2. So root 18 add root 2. Okay, so root 18 can be written as root 9 root 2. Root 9 is 3. So we have 3 root 2 and root 2. This is 4 root 2. Now, the whole thing on top is being squared, so 4 root 2 squared is 4 squared times root 2 squared, which is just 2. So 4 squared is 16 times 2 is 32. So the top of the fraction is actually just 32. Now the bottom, root 8 minus 2, well, root 8 can be simplified to root 4 root 2. Now, root 4 root 2 is just 2 root 2. So we have 2 root 2 minus 2. Okay, so altogether, we now have 32 over 2 root 2 minus 2. Now, every term there has a common factor of 2. So, let's divide that away. So we have 16 over root 2 minus 1. Okay, so we now need to rationalise the denominator. When you have a two-term side denominator, you need to use difference of 2 squares. So, because we have a root 2 minus 1 down there, we're going to multiply the top and bottom by root 2 add 1. So, up on top, we are going to get 16 root 2 add 16, although we don't want to expand the brackets, so just 16 lots of root 2 add 1. Now on the bottom, when you do this, you always get the first term squared, so root 2 squared is 2, minus the second term squared, so we have 2 minus 1, which is just 1. So that is actually our final answer. So they actually wanted it as A times B add root 2, so they don't cry, we should write that as 16 lots of 1 add root 2. Number 21, vectors, 5 marks, probably pretty tricky. So, OAB is a triangle times OPM and APN are straight lines. M is the midpoint of AB. O to A is little a, O to B is little b. OP to P to M is in the ratio 3 to 2. We want to work out the ratio ON to NB. Good times. Alright. Okay, so this one is going to take some explaining. So, first of all, get the info on here that we know. So we know O to A is little a, and we know O to P is little b. We also know that OP to PM is in the ratio 3 to 2. So what that means is, altogether that line is in 5 parts. OB is 3 of those parts, P to M is 2 of those parts. Now then, because we know APN is a straight line, we know that AP and PN are parallel. When vectors are parallel, they are multiples of one another. So the way that I'm actually going to think about it is that A to N is a multiple of A to P. So let's write that down. So A to N is some multiple that we're going to use K. So it's some multiple of A to P. So the first thing we're going to do is we're going to try and find A to P. So how are we going to do that? Well, we could do that if we knew how to get from O to M. So let's first of all work out O to M. So to get from O to M, we could go up to A and then down to M. Because M is the midpoint of AB, A to M is half of A to B. So A to B is minus A plus B. So A to M is half of that. Now then, O to M so to get from O to M, we're going to go up to A and down to M. So that's going to be A minus half A add half b. Now that then is 1 half a plus b. So that gets us from O to M. Now we can work out O to P. So we know that O to P is 3/5 O to M. So O to P is 3/5 of 1 half A plus P. So 3/5 times 1 half A plus B. So if we multiply the fractions, O to B is 3/10 of A plus B. Now that we know O to P, we could work out how to get from A to P. So we would go from A down to O up to P. So we can now say that A to P so that's going to be minus A add 3/10 A add 3/10 B. So that is minus 7/10 A add 3/10 B. Now to make that a little bit less scary, we could factor out a 10th and say then that A to P is 1/10 lots of minus 7A add 3B. So that is now what we have for A to P. So we can go back over here now and say that 1/10 A to N is K over 10 lots of minus 7A and 3B. Okay then, so from here we can now start thinking about O to N. So we now know how to get from A to N. So to get from O to N, we're going to have to go up to A first, and then down to N. So O to N is going to be little a add K over 10 lots of minus 7A add 3B now then, we know that if we expand this, we are going to get A minus 7ka over 10 add 3kb over 10. From this, we can actually work out the value of k. We know that really, to get from O to N, there's no A component. It's just directly along some amount of the little b factor. So, we know then that A minus 7ka over 10 must equal 0, again because we want no A component. So if we divide through by 8, we get 1 minus 7k over 10 is equal to 0. So we can get 10 is equal to 7k. So k is equal to 10 sevenths. So now that we know the value of k, we now know O to n is equal to, well, we know it's just the 3kb over 10, so that then is going to be 3 over 10 times 10 over 7 b. The 10's cancel out, so we get 3 sevenths b. So what that tells us then is altogether this bottom line is in 7 equal parts. The first part, O to n, is 3 and b is 4. So O to n b is 3, 2, 4. Completely disgusting question, but there we go. 22, the final question, and just when you think it can't get worse, another vector monstrosity, 6 marks. Yeah. Right, so there are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. There are more than 12 pens in the box. So let's stop there. So there are 3 more blue pens than green pens. So let's say there are X green, then there are X add 3 blue. Then we know the total is 2x add 3. And for some reason we want to know that is greater than 12. Okay, so Simon is going to take at random 2 pens from the box. The probability that Simon will take 2 pens of the same colour is 27/55. Work out the number of green pens in the box. Okay, good times. Right. So, I suppose what we can do from this inequality is find the minimum number of green pens that must be in the box. So if we take away the 3, 2x has to be greater than 9. So x then is greater than 4.5. So the number of green pens in the box has to be greater than or equal to 5. Okay, right. So now we need to think then about the probabilities. So the probability of taking 2 pens of the same colour is going to be the sum of the probabilities of 2 greens or 2 blues. So the probability of green, well, the probability of taking the first green is going to be x out of 2x add 3. And then taking a second green, well, there's going to be 1 less green in there and 1 less pen in total. So that's going to be x minus 1 over 2x add 2. So that's going to be x times x minus 1 over 2x add 3 times 2x add 2. Lovely. Okay, then with the blues, so the probability of blue is gonna be, so on the first one there are x add 3 blues, so that's x add 3 out of 2x add 3. And then if we've already taken a blue, we're now going to have x add 2 blues out of 2x add 2. So that is x add 3 times x add 2. All over 2x add 3 times 2x add 2. So the probability of 2 pens of the same colour are these two added together. Now when you add fractions, you never add the bottoms. So the bottom, they both are the same, is 2x add 3 times 2x add 2. And the top is going to be x times x minus 1 add x add 3 times x add 2. Now, we also know what that is numerically. It's 27 over 55. Let's hope to God we can simplify it a bit faster. So, yeah. Okay, let's expand the top. So we're gonna get x squared minus x. And then we're gonna get x squared add 5x add 6. So that's all over 2x. Add 3 times 2x add 2. Okay, so there is at least going to be one common factor that we can take out. So that's good news. So up on top, let's simplify. So we have 2x squared we have a minus x plus 5x, so that's plus 4x. Then we have plus 6. All over 2x add 3 times 2x add 2. Okay, so the common factor I mentioned is 2. Every term on top has a factor of 2, and that second bracket on the bottom has a factor of 2. Now, because the bottom is all multiplying together, that 2 could come out the front. So, I'll show you. This is 2x squared. Add 4x add 6. Over. Now if we bring the 2 out, we have 2 times 2x add 3 times x add 1. So if we now divide top and bottom 3 by 2, we get x squared. Something nice might happen, maybe. So we get x squared add 2x. Add 3. No, there's no nice thing. And then that is over 2x add 3 times x add 1. Okay, so let's expand the bottom. So we have x squared add 2x add 3 all over 2x squared and then we're going to get 3x add 2x, so that's 5x. Add 3. Now, at this point, it's time to get the numbers involved. So we know this probability is 27 over 55. So what we're going to do now is get rid of the fractions. So we're going to multiply through by 2x squared add 5x add 3 and multiply through by 55. So we're going to get 55 x squared add 2x add 3 is equal to 27 times 2x squared add 5x add 3. We're going to expand both sides. So, we are going to get 55x squared. Add 110x. Add 165. And on the right, we are going to get 54x squared. Oh, that's nice. Add 135x. Add 3 times 27, 81. Okay, we're now going to want to get everything on the same side, and hopefully it's about to get nicer. So, if we subtract 54x squared from both sides, we get left with 1x squared. If we subtract 135x, we're going to get minus 25x. And if we subtract 81 from both sides, we get 84. It's just not getting any nicer at all. Okay, so now we need to try and factorize this. So, what adds together to minus 25 and multiplies together to positive 84? Both numbers are going to need to be negative. Okay, so 2, not going to do it, 4 goes into 84, 21 times, that'll work. Okay, so we get x minus 4 times x minus 21 is equal to 0. Now, either x is 4 or x is 21. Remember that x is the number of green pens in the box. If x was 4, 2x add 3 would only be 11. We were told the total number of pens in the box is greater than 12, so x has to be 21, and that is officially the hardest GCSE question I've ever seen. Good times. Okay then guys, that's finally the end of that paper. To be honest, relatively speaking, I do think that was very hard. I think these papers are actually getting worse as we go. If you found it useful, don't forget to give us a thumbs up, get subscribed, share with a friend, they may need help too. Drop us a comment down below with any requests. Take it easy, take care.